Once again, you all are welcome in my channel. In the last video, I showed you how to how to solve these two questions using K-map. Now I'll proceed further. The next very important question is write a short note on error detecting and correcting codes. This is very important question and asked several times in the exam. And I hope maybe in this year also this will be asked in the exam. So error detecting is a detection code. Actually, sometime whenever this error detecting code is used in the digital transmission. Now, what is this digital transmission? Let us suppose we have a transmitter and we have a receiver. We have a transmitter section and we have a receiver section. Whenever a signal is sent, what will happen? There are certain environmental variables like which will create a noise in the signal, and sometimes it distorts the message. So how to get to know whether our message get distorted? For that we need a error detecting codes. So this is certainly true of voice messages. So by means of digital messages, we mean a sequence of zeros and ones which is encoded in a given message. So we will seek to do it, add more data to a given binary message. Adding such is called error detecting code. So I hope you came to know about you understand this error detecting. Now a common type of error detecting is parity check. This is very important and we already did. In parity check there are two kinds of parity that we already covered. If you don't have an understanding of this, I'll advise you to just go and watch the parity video where I show you there are two kinds of parity. One is even parity in which the even number of ones, and one is odd parity in which there are odd number of ones. So we'll move forward. Error correcting codes. Error correcting codes are the codes which are used to correct the errors. So we will also try to add data to the original message so that we can detect if errors were made in the transmission, and also to figure out or what the original message was from the possible correct message that was received. This type of code is called error correcting code. In general, a code is said to be error correcting code if the correct code can be deduced from the erroneous word. Hamming code is one of the example. So this is again a very important question. Next question is access 3 code and gray code. I thought this topic is very important. Access 3 code, in which the very important point with the access 3 code is the access 3 code. It is 3 more than the BCD. This is very important, not binary. So next is gray code. In gray code, every number differ from the preceding number by a single bit. Successive number by a single bit as shown here. So I'll advise you to, when this type of question will be asked in the exam, you have to write a note and one example. So this question I thought you all know what is the difference between access 3 code and gray code. In fact, you know how to convert these code into each other. So we'll move forward towards the next question. The next question is very important. Show how 16 to 1 multiplexer can be obtained from 4x1 mux. So actually this diagram is designed here horizontally, but you can design it vertically also. You need 4x1 mux, and you have to make all the functions to the fifth one. So by using this selection line, first of all you have to select there are 4 selection line A, B, C, D. By the combination of these you can select the different multiplexers. If you do not understand this question, I'll advise you to just go and watch my video in which I told you how to design a higher order muxes. So we'll move forward towards the next question. Draw and explain block diagram, truth table and circuit of 1-bit comparator. Very important question. 1-bit comparator is very important question. So comparator is what? Comparator is basically a circuit, digital circuit, which is used to compare the 2 bits. So here are the 2 bits X and Y, and we want to compare it. So this is the truth table. If 2 bits are same, then the A is equal to V is 1. When A is bigger, then A is bigger is 1. When B is 1, then B is 1. When both are equal, again the equal sign is. So this is the diagram of the 1-bit. I hope you understand this truth table. So this is the diagram. To draw this diagram, basically first of all you have to convert this into the expression. For A greater than B, this is very important. The 1 is only here, which is equal to B bar A. So see, this is B bar A. A is greater than B. So this is B bar A, and similarly for A is equal to B, this is for A is equal to B, your equation must be B bar A bar plus AB. So see, for A equal to B, this is same A bar B bar plus AB. So and at the end, for A less than B, this is B A bar. So B A bar. So here it is shown B A bar. So I hope you understand this. This is very important. This is very simple. This is A bar. You can design it your own also. This is B A bar, and this one is B. So this is A bar B, and here it is A. This is B bar. So this is A B bar. Once you put it, this is the one answer. This is another answer. Or when you put these two into the NOR gate, you will get the third answer. This is very simple. So we'll move towards the next one. Draw a truth table, Boolean equation and circuit diagram, full adder and full subtractor. This is very easy. I think I should have to skip this question for you peoples. You just have to, but I'll advise you to, whenever this kind of question will be asked, you have to design its truth table. After that, you have to solve it using the K-map and the circuit diagram. These three things are needed. So similarly for the subtractor, this is very easy. You can design it your own. Now very important question we will discuss, that is what is demultiplexer. Explain with the help of suitable diagram and logic circuit of 1:16 demultiplexer. So demultiplexer, it is basically which it's a kind of digital circuit which perform the opposite of multiplexer. It is shown here. So this is 1:16 demultiplexer. This is a very easy topic, and I'll advise you to just pause this video and do it, and I'll advise here also, you have to go to one of the video in which I told you how this multiplexer, demux and decoders are different from each other, and this is a simple question. I think you can do it. So the next question is very important, that is mode triple counter and decode synchronous counter using JK. This is decade synchronous counter using JK flip flop. So mode triple counter, I already told you, mode means which a counter which counts till 8 from the 0. So it will require, since it has to measure 8, count till 8. It must be consisting of 3 flip flops like shown here, flip flop 1, 2 and 3. And how it start working, this is very important and explained very easily here. See, this is a diagram, clock pulse, these are the 3 inputs. So you have to draw this diagram, and using present state and next state, you have to first of all create this, and after creating this you have to make its truth table and solve this using K-map. After solving this K-map, you can design it. So this is already shown in one of my video, how to design counters. I'll advise you to just go and watch that video. So next question is decode synchronous counter using JK flip flop. So for JK flip flop, this is very important. Decade counter means you have to count till 10. So this will be consisting of 4 flip flops, and the procedure is remain same. You have to state the diagram, then you have to use the excitation table, K-map and draw the circuit. And this question is already addressed in one of my video where I show you how to design the different kinds of counters. So this remains again a very important question. So we'll move towards the next question, and next question is very important. What is shift register? Draw circuit diagram of serial in parallel out and parallel in serial out using JK flip flop. So this already we covered in the notes, and I'll advise you to just go and watch the video on the shift register and do this question practically. So again, this video will be go lengthy, so we'll meet soon in the next video. Till then, stay tuned. Bye bye.